Hey guys, welcome back. So we're going to solve absolute value today. Yesterday we talked about absolute value problems and we said that when you have the absolute value, it is the distance from 0. So if you have a negative 9 inside the absolute value bars, it's 9 units from 0. Okay, so when we're solving an absolute value problem, you're trying to determine what two numbers are both a certain distance away from 0. So if I tell you that the absolute value of g is equal to 9. You know that in order to solve this, you would have said, well, I know that on my number line, I have 9 here and I have negative 9 here. Both of which, if you were to move, you would move 9 units to the right and you would move 9 units to the left, both giving you an answer of 9. So in this case, g can equal 9 or g can equal negative 9. Either of those, when you were to substitute it into g, will give you 9 as an answer. So here are some examples. When you have the absolute value of m equals 5, you have m can be 5 or m can be negative 5. Because each of those, when put right back into m, gives you the distance from 0, which gives you 5. Can you end up with an absolute value of negative 13 when you don't have the negative out front? The answer is no. So in this case, this is a no solution. But in example 3, see how you have the negative out front? This is when you have that negative answer. So you would have f equals 10 or f equals negative 10. Because if we were to check this and say negative absolute value of 10 is going to give you negative 10, think about what we did yesterday. We took the absolute value of 10, which gave us 10, but we also brought down that negative, so that works. Here's another example. Absolute value of d is equal to negative 24. Since you don't have the negative out front, this again is a no solution. The negative is out front, and you have a negative in your answer. If those match, then y can be 6, or y can be negative 6. And in this last one, z can be 8, or z can be negative 8. This is where it gets a little bit more confusing. Absolute values with operations. So now we have that operation inside, but we don't know what x is. So in order to do this, you have to come up with two equations. Okay, one is going to be a positive, and one is going to equal the negative, just like we did up top. So you're going to get rid of your absolute value bars, and you're going to say x minus 2 is equal to 3. And then we also have x minus 2 is equal to negative 3. Add together your constant. So since this is negative, you add it, and you're left with x equals 5. Same thing here. Since you are minusing 2, you're going to add 2, and x is going to equal negative 1. So those are your two answers. Let's try this one. X plus 5 is equal to 11. So you have to have two equations that x plus 5 never changes. Only the value of the 11. So you have minus 5. Because it's addition, you have to subtract to both sides. 11 minus 5 is 6. And subtract 5 on this other one, and so you have x equals negative 16. And those two are your answers. This last one, you have x plus 3 equals 9, and x plus 3 equals negative 9. You would subtract 3, and so you have x equals 6. Also subtract 3 here. And since you have two negatives, remember you can add them together, giving them that negative symbol. 9 plus 3 is 12. So these are your answers. So just to recap, make sure that you set up two equations. One of them is equal to a positive, one of them is equal to the negative number. The number inside does not change. Also, when you have subtraction, make sure you add to solve. When you have addition, make sure you subtract to solve. What I want you to do right now is go on and try your in-class practice. Once you finish that, raise your hand or go check your work on the board. And good luck on your quiz. Have a great day.